Hello, everybody. My name is Jakub, and I would like to welcome you on this short session. I hope you are having a good session, good experience in this conference, and I hope you will find next couple of minutes interesting. Today, my only goal is to show you how in Samsung R&D Institute Poland we leverage AI technology, including deep learning, of course, to play with fascinating world of sounds and audio signals. Before I jump into the main topic, let me give you some super short introduction about myself. My background is sound and vision engineering, and I'm working in Samsung since, well, few years already. But what's important, since almost 4 years, I do have a pleasure to lead one of the best R&D group in Warsaw, and probably in Poland, focused purely on audio intelligence and its applications. I also do love speakers, amplifiers, and build my own in my free time, and this is my hobby and passion. Okay, but let's get back to the main point. Today, I will invite you to explore with me sound of AI applications. We will talk about machine listening, deep signal processing. Also, please know that what we will discuss today is just a small portion of actual activities, but due to time limits, I will not go into much details. I will finish with some highlights of what to expect in the future, but also with, I hope, important recommendation for all of you. Okay, so why I'm and my colleagues and we here in Samsung Warsaw are so obsessed with audio and sounds. In AI landscape, there are plenty of domains that are fascinating. We do have conversational AI, Bixby, Amazon Echo, Google Now, and many other NLP-driven applications. We cannot forget image processing area, which in fact enabled deep learning like 10 years ago. There is also data-driven AI applications with recommendation services, business intelligence, and so many other fascinating applications. But today, we will focus on sound AI and some of its applications in real-life scenarios. Okay, so let's start with machine listening. And in order to show you rather than talk about it, let me present you some audio example. Please listen and try to guess as much as possible from this short audio file. We just listened only 10 or 15 seconds of audio signal, but we already learned so much about the context and of the device and its user. We do know that someone is in a noisy place, perhaps some restaurant, perhaps dinner time. We also notice that something potentially dangerous just have happened. There was some glass breaking followed by charge cry. And of course, this is super simple example, but I hope this gives you just the feeling of sound recognition area is and what kind of applications, use cases, scenarios it might enable for you. Personally, I started my AI journey with images, as probably many of you. This is why I would like to show you how computers actually see sounds and audio signals. For this, I have prepared a few spectrograms, and I'm wondering if you already noticed what kind of sounds they do represent. Let me start here with the right upper one. On the x-axis, which corresponds to the time, you can see two rapid events. They do happen almost in every frequency range. After each one of them, there is this natural sound decay. This is an obvious example of explosive sounds, probably related to gunshotting. On the bottom left, we see typical emergency siren with this ee-yon, ee-yon, ee-yon. Left upper one is interesting and probably not so easy to guess, but you need to trust me that this is actually my charge crying. The last one is just a nice example how some artists mess with spectrograms in their music production. Okay, so for now we do know that the sounds do tell the stories and we are able to observe them. So this should not be a surprise for you that sound reasoning is not something new, and it was, is, and will be utilized in multiple applications. AI-driven techniques are utilized in military, gunshot detection, detectors and localizations in combat field, but also much closer to us. Multiple cities are already filled with audio sensors serving security-driven services 24/7. But what about consumer devices? Yes, sound recognition is already here. Here I would like to focus on the one that my team have contributed directly to. This year we have developed and commercialized highly accurate dog barking detector, which is utilized in pet cat scenario introduced to our cleaning robot. But this is just the beginning. Detecting sounds at home combined with security service, already here. Predictive maintenance in a space, and not only, consider it done. How about cars? Believe me or not, but Skoda is already making it trials. Healthcare and other applications will utilize sounds sooner than you think. I will deliberately do not go into technical details, but for sure you are all aware that all of these are DNN-driven techniques. Let's move on, because sound AI, as far as we understand it, it's not only about recognition, detection, and classification. We are able to use deep learning for signal processing and do really amazing things with this. But again, before jumping into examples, audio processing is easy, isn't it? Well, yes and no. You need to understand the physics behind the signals, as well as understand that normal input to our engines is composed not only with the sound source we are interested in, but also involves other sources, background noises, as well as reverberation, room influence, and so on. You need to also be aware that the same acoustic event sounds completely differently due to microphone characteristics. We are contributing to multiple products, and believe me or not, but it's not always easy to use the engine tailored for mobile device in refrigerator, for instance. But let's get back to examples. First, speech enhancement. Especially in COVID area, we have noticed multiple AI-driven noise extractors for teleconferences and this kind of stuff. And we also do such applications here in Warsaw. And today I would like to present you just two simple examples. First one is an application to process user voice notes. While making a recordings, users often move a device, tap on buttons, keyboards, and so on. So let's listen to the original file recorded by the user device.
Welcome, and also to Deborah and Geraldine for organizing this nice event. And I'm pleased to
And now to the processed one.
Welcome, and also to Deborah and Geraldine for organizing this nice event. And I'm pleased to
I hope you can hear that all artifacts were removed and the file is much cleaner, easier to listen to. Second example shows the potential of techniques that relies on so-called speaker embeddings. Imagine the situation that your device knows your voice and is able to tune to your voice while ignores other voices. Here's an example. The input file.
They did a really great job.
That was put it to one of our engines and the output of this.
I saw some good things.
In this example, we did knew the target voice that we wanted to focus on, but we also do work in a blind source separation area. And this is shown in this last example. So there is a mix of two signals.
To the Hebrews, it was a token that there would be no more universal floods.
That was separated by one of our DNN engines created here in Warsaw into two sound objects. The first one.
To the Hebrews, it was a token that there would be no more universal floods.
And the second one.
No such remedy has ever been prepared.
But this is not all. We do utilize AI for making active noise cancellation better. We do experiment with neural spatial beamformers in order to provide even better listening experience. We also prototype a lot to enable new kind of experiences. We also do incorporate other modalities and not only focus on audio. We do see a lot of potential in audiovisual correspondence learning, in which we combine audio features with visual ones. We also work on many other areas, but to get more details, well, you need to join our team. I would like to finish this short session with some forecast what to expect in the future. And for sure, we will see new applications, object-based audio, spatial experiences, augmented listening, 3D audio. This is coming. But how to enable these new experiences? Will we need more training data? Just a fun fact, some time ago, we had broken 13 tons of glass in an anechoic chamber in Poznań. So yes, we will probably record better and more sounds to meet your expectations. We will also incorporate new architectures and probably mess with, I don't know, semi-supervised, unsupervised approaches. But all of this is a natural way for every AI application. So what's the real problem for sound AI? What is the challenge in front of us? In fact, there are two. First one, latency. If we target, for instance, TWS, so we want to combine headphones with AI features, they need to work instantly. Latency of introduced filters, engines, processors need to be extremely low. We are talking milliseconds, microseconds in most of applications. And second is the actual commercialization on the device. We do use CPU, GPU, and NPU on a daily basis. This new hardware is exciting, but it's not easy to deploy in the situation, for instance, when one TV can be equipped with 3 different types of NPUs, and each of them support different types of DNN layers. My point here is you can make very nice DNN model that will work great on your simulation, amazing F1 score accuracy, and so on. But believe me, this is just a starting point, and taking this engine to real product is way more complicated than you might think. Last point, I also need to point out that audio intelligence is just a piece of AI team activity. Here in Warsaw, we work with recommendation services, user profiles, big data applications. We do have one of the biggest NLP focus group. They do pretty amazing stuff, as they do focus on dialogue systems, including chatbots, question answering, and knowledge bases. We also work on machine translation that is actually better than Google's one, and use text mining techniques for text analytics. Also, our data acquisition team provides us with data that we need our work. Last but definitely not least, vision processing, video analytics, eye gaze tracking, new massive projection, augmented reality, stereo camera, depth camera. Just few examples of what's going on in AI team in Poland, in Samsung R&D Institute Poland. Moreover, we are having a lot of good time, and we also take part in competitions, publish scientific papers, and so on. If you're interested in more details, please contact me directly. I will wait for your emails. Also, please visit our webpage, in which you will find more details about AI team, but not only AI team, because there are other amazing R&D teams here in Warsaw. And well, thank you for your attention. I hope it was interesting for you. Please contact me and have a great evening. Thank you.